as we're moving forward with our derivatives, we also got to talk about some of these higher order derivatives, which is like first derivative, second derivative, third, fourth, fifth, sixth derivatives, forever as long as we can, okay? In physics, we can use these different levels of derivatives to interpret and to discover and apply it to certain ideas. So we've talked about this a couple different times, but when we're in y, our y value tells us the position of a particle or whatever we're dealing. We're tossing a ball up in the air, that's going to tell us the height that the ball is at. When we take the derivative of that, we get dy dx or dx dt, depending on what our variables are. That's going to tell us the velocity of that object. Well, if I take the derivative of velocity, that's the change of velocity, that looks like this. So we're going to do d squared y over dx squared. What's happening here is we're looking at the change in meters, but we're looking at the change in time twice. So we get the second derivative, and the time is changing twice, so we get that x squared. This is acceleration. So the derivative of velocity is acceleration. And then again, if we take the derivative again, now it's the third derivative. This is called jerk. So again, we've talked about different types of notation. This is one set of notation to show that. Another one would look like this. If s of t is my position, if I take the derivative of s of t, that's going to give me velocity. So if it's just written as v of t, we know that that's our first derivative of position. Well, now if I take the derivative of velocity, that's going to give me acceleration. Acceleration is the second derivative of position, like this. So that's a second derivative. If we take a derivative the second time, we're now dealing with acceleration. And what that means is we took the derivative once to get velocity, we take the derivative again to get acceleration. But now I'm going to take the derivative of acceleration. I don't know really how they notate jerk, but I'm going to go ahead and just say J for jerk. This is the second derivative of velocity, but it's the third derivative of position. So what you're going to practice here is just taking the derivative multiple times of the same problem. So we did one in class that's similar to the following. If I said the position is given by 3x to the fourth minus 2x cubed plus 6x minus 3, and I want to know jerk. So to get there, I have to go through each step. So I have to get to velocity by taking the derivative of position. So that's 12x cubed minus 6x squared plus 6. So position to velocity. I need to go to jerk. So that means I have to pass through acceleration. So I take the derivative again. So that's 36x squared minus 12x. And then to get jerk, I just take the derivative again. So that's going to give me 72x minus 12. So just taking the derivative of the derivative is a higher order derivative. Okay, good luck with your practice.